This is it. 6.1, nice and easy. Rational expressions is a fraction with a variable in the denominator. So an unknown, an x, a y, and a z, whatever it is going to be. One big thing that we have to work on a lot, and these will not go away, you're going to use non-permissible values. I tend to abbreviate it to NPVs. And this is any value for the denominator or for that variable that will make the denominator equal to 0. Because if you grab your calculator right now and go 2 divided by 0, what does your calculator do? Nope. Doesn't work. Gives you an error, right? Gives you a syntax error. It's all fun and games until someone divides by 0. Dividing is the action of putting them into groups. So when you take 6 and divide it by 3, you're saying I have 3 groups of 2. But if you have 0 groups, how does that work? No clue. The calculator doesn't know, will fall into a black hole, it won't be good. So non-permissible values, we have to find those often. And we're going to practice that. To solve for a non-permissible value, set the denominator equal to 0 and solve for the value of that variable. When you simplify a rational expression, you must do your non-permissible values before you cancel anything out. All right. Shh. Okay, I'm going to start on example. So we're going to identify the non-permissible values. I like to call these NPVs. So if you hear me refer to that, it's just because I want to make it easier. I'm going to zoom in a little bit. Okay, I'm going to start at C. I'm going to work backwards here. All right. So what I want to do is I want to figure out what can P not equal. I don't want my denominator equal to 0. So I'm going to do kind of the opposite of it. I'm going to take P squared minus P minus 12. What number is it going to equal to 0? This, ladies and gentlemen, is chapter 4. Right? You've done this already. You've done it in chapter 4. So anytime I have a squared, I'm going to do what? I'm going to factor it or quadratic formula, right? This one, what do you think? Factor or quadratic formula? Factor. Negative 12, factors that add up to negative 1. 12 minus 4 and 3. Because they have to multiply to negative 12 but add to negative 1. So this would be P minus 4, P plus 3. So then we're going to set each factor equal to 0. So P minus 4 equals 0 and P plus 3 equals 0. Cash, there's booklets, new booklets right there. So P equals a positive 4 and P equals a negative 3. So what we've just done is we've identified the two values that P cannot equal. So we're going to say our NPVs. P cannot equal negative 3 or positive 4. And that's really what I'm looking for non-permissible values. I'm very good with that. So it's a lot of chapter 4 in a situation like this where we're solving, but we're saying P cannot equal those because if I put a negative 3 in here, so if I actually do that, if I have negative 3 squared minus negative 3 minus 12, I'm going to have 9 plus 3 minus 12. Oops, sorry, you guys can't see that. What does that give me? That gives me 0. So if I put a negative 3 into this, I'll get a 0 for the denominator, and I cannot have a 0 on the denominator. That's like an absolute no. Okay. Yep.
Do we only do this thing for the denominator?
Always the denominator. The numerator can be 0. That's not a problem. If we go 0 divided by 2 in our calculator, it's going to be 0. It's only when 0 is on the bottom. So NPVs are only related to the denominator. No zeros on the bottom. Okay, let's do B now. Let's work backwards and we'll do B. This one is already factored for you. It's in factored form. So I'm going to set that equal to 0. So I'm doing the same thing. It's already in factored form. You can multiply it through, but then you'll just have to undo it, and we'll be right back to here. So I'm going to have x is equal to 0 and 2x minus 3 is equal to 0. Lots of people miss this one, and that's not great, but so our NPV is x cannot equal 0 and 3 over 2. You're okay if you put that as a decimal as 1.5 like that. That's not gonna lose my mind over that, but we're in a fraction unit. Maybe stretch your knowledge and use fractions. Okay, do you guys know what I mean by monomial? One what? One term.
Yes.
What separates terms in a polynomial?
Addition or subtraction.
A plus or a minus sign, right? Are there any plus or minus signs here? No. So I'm going to give you guys a trick to remember this. When you have a monomial, the non-permissible value will always be 0 because everything's getting multiplied together. So if s is 0, what's the denominator? Okay, if r is 0, 0. So if you have a monomial, you don't have to do any of the solving. You can just simply state that my NPV is s cannot equal 0 and r cannot equal 0. Because if any of those, anytime you multiply by 0, you get 0. And if you look at this, this was a monomial. This x was a monomial. There's no other terms with it. What was it equal to? 0. So it's just kind of a quick way anytime you're dealing with monomials. So a single term, your non-permissible values will be 0. And please note that I'm using the not equal to sign. So it's crossed out. The equal to sign is crossed out. S cannot equal 0. All right, example number 2. So this is a little bit of grade 10, a little bit of grade 11, and a lot of brand new stuff. So anytime you're going to simplify, what I want you to do is step 1, I want you to factor everything. All right, step 1, I want you to factor everything. So that's both top and bottom, both numerator and denominator. So in the numerator, nice and easy, it's not a squared, so I'm not going to have 2 binomials in it as an answer. What can I common factor out of here?
3.
A 3. So I have 3 on the outside and then x minus 2 for my numerator. And then on the denominator, that's complex factoring. I'm going to pop over to my scrap paper here. So I got 2x squared plus x minus 10. So what do I do here?
Take out 2.
I can't take a 2. Because if I take a 2, I can come out of 10 and it can come out of 2, but it can't come out of 1. So complex factoring, I multiply those two. So I'm looking for the factors of negative 20 that add up to a positive 1.
5 by 4. Negative.
Right? We want a positive 5 because it's a positive 1. So then we rewrite the 2x squared gets rewritten. And then I'm going to rewrite this into 2 terms. So plus 5x minus 4x, and the 10 just gets rewritten. I've noticed some of you guys skipping some of these steps, and it's not because you don't know them. I think it's just because you're rushing to get some assignments done, and some factoring's not coming out quite proper. What can I common factor out of here?
X.
Any numbers? I can take out a 1, but same thing. So it's going to be that. What am I going to common factor out of these guys? 2. What kind of 2? I gotta take out a -2. So remember, if I multiply this -2 back in, I should be back at this part right here. I know I've done it correctly if these two things are the same. So I have 2x plus 2, my notes in there. So 2x plus factor, x minus 2 was the other factor. Okay? All right. Now step 2, Step 2 is going to be your non-permissible values. I want you to do your non-permissible values. Remember that they are denominator only. Can you do it by just looking at them? Okay. So we're going to state our NPVs off to the side. So x cannot equal -5/2 and 2. If you are uncomfortable with that, if that is not yet in your skill set, that is okay. We're just going to take each one of these factors, set them equal to 0. So 2x plus 5 equals 0 and x minus 2 equals 0. I'm going to minus 5 from both sides and then divide by 2. That's where I get the -5/2. And I'm going to add 2 to both sides. So that's the +2. So if you are here, if you still need that step, don't skip it because you think you should be there, because that's just going to mess up your answers. So we've done our non-permissible values. And then the next step, I didn't leave. Okay, so the next step I put as cross out. So step 3 is cross out, but it's top and bottom. It has to be the same factor from top and bottom, and they have to be exactly the same. So what is exactly the same here? X minus 2, x minus 2. There's the same thing on top and bottom. So what's x minus 2 divided by x minus 2? 1. Anything divided by itself is 1. So when we talk about canceling it out, really what we mean is dividing it and getting an answer of 1. So my answer, my simplified answer is going to be 3 over 2x plus 5, where x cannot equal -5/2 and 2. So I put a comma in there because these are what we call restrictions. And you had those in the chapter 5 unit.
Are they on the test, restrictions?
No, I think I left them off the test.
Thank you.
Okay, so here's the thing. If you've stated the NPVs clearly somewhere, if they've been labeled and they're NPVs, if you forget to put them in the answer, like you only give me that for the answer, I'm okay with that. Okay? I'm okay with that. All right. B. B is a tricky one. Step 1, factor everything. What can I take out? 2. So I'm going to have, I'll use a different color. What do you notice about the bottom there? What do we call that?
Yeah.
Difference of squares. Perfect square in the front, perfect square in the back. So this will be m plus 3, m minus 3. Okay, so I factored everything, top and bottom. Step 2, I'm going to do my NPVs. M cannot equal plus or minus 3. You can list them as -3, then comma +3, that's fine. If you want to list them as plus minus 3, that's okay too. It's just different ways of listing the same stuff. We're mathematicians, we're efficient, so I only had to write 3 once here. Is there anything I can cancel out?
3, no, yeah, no. Can you? No.
It's not exactly the same, correct? But there's something we can do to change it. If you notice that these are in the wrong order and they're the wrong signs, so down here m is positive, but m is negative here. 3 is positive, but 3 is negative here. you can go up here and you can common factor out a -1. If you take out a -1, so essentially you're dividing everything inside the bracket by -1, you're going to have 2 times -1 times -3 plus m.
Easy.
Yeah, and it's a useful thing because you're going to see this a little bit. It's going to pop up places, I promise you. That's the same thing as saying -2 m minus 3 over m plus 3 m
You
minus
have to
3.
write prescriptions.
We're not quite done yet. I just want to say that these two things are equivalent. I just multiplied these two to get my -2, and I just switched the order of them just so it looks exactly the same. You don't have to do that. So these two will end up canceling each other out because they're exactly the same, and I'm left with -2, oh, I'm using a different color, -2 over m plus 3, where m cannot equal plus minus 3. Yeah. Because in this line, the 3 is positive, right? So if you take a -1 times by a -3, that will take you back to the positive 3. So by factoring out a -1, it's going to change the signs on everything. Okay. Okay, exciting stuff. All right, example number 3, a little bit more complicated. What's the non-permissible value for x? Okay, what's step 1? What do we do? Step 1 is factor everything. So let's factor the numerator and the denominator. This will help us answer everything else. Did everybody see that the numerator was difference of squares? 16 is perfect. Numerator, yeah. And for the denominator, what am I going to take out?
2.
I'm going to take out a 2. So step 1 is factor everything. Step 2 is non-permissible values. And part A says, I want it in terms of x. If you have a constant here, it has no variable in it. So you don't have to solve this one out. You only have to solve the ones with a variable in them. So we have 4x minus 3y equals 0. So all I want to do is I want to get this x equals. I want to get x on one side and everything else on the other. So I'm going to add 3y to both sides.
I don't understand how there's a 2 and it's like, we just completely leave it off and just...
Well, because non-permissible values are for variables. Non-permissible values are all about what that letter cannot be. And because 2 doesn't have a letter, like there's no, if it was an x out there, then we'd have to deal with it. But because it's just a number, there's no variable to solve for.
If it was 3xy and you took a common factor x out, then we have...
Exactly. Yep. Yep. All right, so what we've just found is our non-permissible value. Non-permissible value, x cannot equal 3y over 4. So it's in relation to y, which is weird. And sometimes that happens with two variables. Not the end of the world. This would be the answer to A. That whole thing right there would be the answer to A. Now B is asking to simplify the expression. So what can I cancel out?
4x minus 3y.
So we're left with 4x plus 3y over 2, where x cannot equal 3y over 4. And that's the answer to B. Now, some of you might be like, oh, but 4 can be divided by 2. And I agree with you, it can. But that 4 has to be divided into both this one and that one. So if you wanted to simplify it any further, you could go 2x plus 3y over 2. So this and this are the exact same, but that 2 has to stay under both of them. I only ever get rid of it if it divides evenly into both of them, and in this case it doesn't, so I don't normally do that, just because I find it a little bit confusing. Okay, so now I want you to evaluate the expression when x is equal to 2.6 and y is equal to 1.2. Doesn't matter what expression you substitute into, the original or the simplified. It doesn't. I want you guys to do the simplified and I will do the original. And you guys all are comfortable with simplifying or substituting, sorry?
What? I know 4.4.
Hmm.
The hell?
So just remember that you can put it all in your calculator. Like my calculator is smart enough, if the user is smart enough, and hopefully I am, to put it all in at once. I have to put that numerator in brackets, and same with the denominator. So if you're trying to put it all in at once in your calculator, just know that there is some complications. That's it, non-permissible values. Easy peasy lesson.
Why am I getting 4.4 scattered?
Okay.